looking at the world of discrete random variables. Discrete means exact values. Random variables means probability of something. And then when we do that, we use capital letters. In other words, probability of capital X, probability of capital Y, probability of capital A, whatever. We use capital letters when talking about random variables. Let's look at a situation. X, so this is capital X, is the number of siblings. Siblings are brothers and sisters, those of you who don't know. So I'm going to make a table, X, probability of X. So X is my random variable. I could have 0 siblings, 1, 2, 3, 4. Let's go up to 5. 5 siblings. It's a lot of siblings. So 0.15, so 15% are an only child. 23% are, they have 1 sibling. 41%, 2. 14, 3. 5%, and 2%. Now if you add up all these probabilities, it should equal 1. Okay, that is the requirements for probability distribution. They must all be between 0 and 1, and the probabilities must all add up to be equal to 1. Number 1. What is the expected number of siblings? Now, that word expected means mean. Okay? And so, what is the mean number of siblings? It is on your formula sheet. It is the third formula on the probability side. And expected, they also say mu of x, meaning mean, is the summation of x sub I, p sub I. Okay? So that means you take each x's, 0, times each probability. Summation, you add 1.23, 2.41. See, this gets tedious, but on free response, you do need to show this work. So you need to show this for free response. Now, if this is multiple choice, you do not have to show all this work, and I'll show you how to just get it to you in your calculator in a moment. Plus 4 times 0.05 plus 5 times 0.02. And we do all that, and hopefully you don't make a mistake in your calculator, get 1.77. The best way, and the calculator, you put x's into list 1, you put probability into list 2, and then you do second, calculate, 1 var stat, now you did 2 lists here, so you're going to have to do L1, so second 1, comma, and then second 2. What that does is it puts a frequency of list 2. And what you look for is the first one, which is x bar, and it tells you it's 1.77, which confirms our answer. Okay? So So hopefully you understand how to use this. It's very important to know how to use the calculator. You want to use the work, the formula, and the work, and obviously the answer for free response, and double check. You don't have to put all that in your calculator, all this stuff here, but you should put x's into list 1, probabilities in list 2, second calculate 1 var stat, second 1 comma second 2, and then that finds our mean. Okay, very important. Number 2. What is the standard deviation? Well, this formula is under the expected formula in your formula sheet. And it says this: var x equals standard deviation squared x equals summation x sub I minus mu x squared p sub I. Now these are each individual x's. This is obviously the mean, and this is the probability. So if you had to show your work, now also this is not the standard deviation. This is the variance, or the standard deviation squared. So if you want to find the standard deviation, technically we have to take square root of all this. We're not going to do all, that's a lot of work, let me tell you. I'm just going to do it for you once, just to show you. But on free response, you do have to show the formula. You take each x sub I, which is 0, minus the mean. So you got to know the mean. If you didn't know it, you have to find it. Squared times p sub I, the probability associated with it, plus 1, that's the next x, minus the mean, squared times the probability, plus, you can see this is very tedious. So you really don't want to do this in your calculator. You'll show them where it came from. You'll do this little bit of work here. But to put in your calculator, there's so many places for you to mess up. So really what we're finding here is the average distance from the mean adjusted by the probability. And here we go. We do all that, and really we would have to take the square root of all that in our calculator. Okay? Because that's the variance. And to find the standard deviation, you have to take square root. So it's very, very tedious. So our standard deviation, we get it from our calculator. Okay, that's from the 1 var stat, L1 comma L2. Okay, after we did from part A. You'll notice we're normally looking for Sx, but Sx will be blank on this situation. So obviously we can't use it this time. So now this time only, we use sigma x in the calculator. This time only. And we get 1.14. Okay? Number 3. Assume independence. Means we can multiply. What is the combined expected number of siblings of 5 random selected people? Well, what's the expected for 1? 1.77. Well, it's independent, so the next one is 1.77. Next one is 1.77. Next one is 1.77. Next one is 1.77. Now, we actually don't multiply these because this is not probability. Okay, this is not probability, so we're not going to multiply. It's expected. So we're going to, and it says combine, so we're going to add them. Where there's 5 of them, so it is 8.85. That's how many are expected. Expected about 9 siblings combined if you selected 9 people at random. Okay. Number 4. What is the standard deviation from number 3? So in other words, 5 people, assuming independence. Well, what's the standard deviation of 1? It's 1.14. Standard deviation of another one, 1.14. Of another one, 1.14. 1.14. 1.14. Okay? You're not allowed to just add standard deviation. You can't add standard deviation, but you can add variances. So you have to square it. The problem is this will give you not standard deviation, it will give you variance. So 1.14 squared. 1.14 squared. So 1.14 squared times 5. Is 6.498. To find the standard deviation, I take the square root of 6.498. So the standard deviation is 2.549. Okay, now you could also see this. Well, let's take a look here. Standard deviation squared x is the square root. Well, no, we want to find the variance, so it's going to be the square root of 5, 1.14 squared. So those of you that are slick, you can say, oh, 1.14 squared, square root of square cancels out, so it's 1.14. I don't know the square root of 5. So to find the standard deviation, it really just takes your standard deviation of 1 times the square root of how many you select, and you'll get the same answer. Okay, so that's a kind of a little slick way of looking at it. If you don't quite understand that, that's okay. Just make sure you understand this part, though. Okay? So that is discrete random variables. Hopefully you understand that pretty well. Good luck. That was the wonderful world of discrete random variables, where we look at exact values, and random variables where we're talking about probability. Okay, and just remember, in your calculator, you put your x's into list 1, your probability in list 2, and then you do stat, calculate, 1 var stat, L1, comma, L2. Good luck and goodbye.